have the same value at 3 pi over 4. Now, that's the time. I want to find a of 3 pi over 4. So I've got to find a first. Take derivative again. Derivative cosine is negative sine. Derivative sine is cosine. So then now we just plug in negative sine of 3 pi over 4 plus cosine of 3 pi over 4. They're both root 2 over 2. The sign is positive there and cosine is negative there. So negative root 2 over 2. And this is negative times positive root 2 over 2. So then this is just negative 2 root 2 over 2 because you have 2 of them. And so that just becomes negative root 2. A. Wait, whatever. Here we are talking about dy dt and finding dx dt. So I'm taking derivative with respect to time. So this is 3y squared dy dt equals 4, 5 minus x now cubed. Derivative of the inside would be negative dx dt. Dy dt is 2. So 3 something squared times 2 equals 4. 5 minus x is 3. 3 cubed times negative, looking for this. So 5 minus 3 is 2. 2 cubed is 8. Negative 8 times 4 is negative 32. This is 6 times, I need to know what y is. So I know what x is. See how you can find y by just plugging in. So y cubed is 5 minus 3 to the 4th. 5 minus 3 is 2. 2 to the 4th is 2, 4, 8, 16, 32. 32 is y cubed. Then y is just a cube root of 32. So this is 6 cube root of 32 squared. Divide by negative 32 to get your answer. And there's your answer. 16, sides and diagonal are strictly increasing, so x, y, and z are all increasing. That means they're all variables, none of them are constant. When x equals 4, y is 3, have all these relationships. What is k at that time? So first of all, our equation is the Pythagorean theorem. Take derivative with respect to time. Plug in what we know. X is 4, y is 3. You can find z very easily by saying 4 squared plus 3 squared equals z squared. That's 16 plus 9, which is 25. So z equals 5. Okay, now we're going to replace. Dx dt is just dz dt. So dx dt is just dz dt. dy dt is k dz dt. And then dz dt is just dz dt. So then now I have this relationship. Let me kind of clean it up. This is 8, 6k, and 10 dz dt. So these two are like terms because they both are just a number with dz dt. So subtract that over, you get 6k dz dt equals 2 dz dt. And then to get k by itself, divide by 6 dz dt. I really hate writing dz dt over and over. This cancels out. 2 over 6 is 1/3. Isosceles right triangle with legs of s has an area of that. When s is that, the area is increasing. Okay. So obviously s equals root 32. The area is increasing at a rate. So dA dt equals 12. At what rate is the hypotenuse increasing? So looking for dH dt. Okay, so dA dt is 12. This is the area equation, so I'm going to take derivative. Bring the 2 down, 1/2 times 2, just leaves me with s, ds dt. dA dt is 12. S is root 32. So then ds dt is just 12 over root 32. That's not my answer. I should know better like that. All right, now I want to find the rate at which the hypotenuse is changing. So think about isosceles means that it's the same two sides and then hypotenuse. So we have our s squared plus s squared equals hypotenuse squared. Take derivative of that, 2s ds dt plus 2s ds dt equals 2h dh dt. You already know s, it's root 32. ds dt is 12 over root 32 plus, I should have combined these, but it's gray. Equals 2, hypotenuse, got to get there in a second, and then looking for dHdt. So hypotenuse, think about you have the root 32 squared plus root 32 squared equals hypotenuse squared. This root n squared becomes 32 plus 32, which is 64 equals h squared, so your height is just 8. Alright, cancel, cancel, 2 times 12, 2 times 12, that's 24 plus 24, which is 48. 2 times 8 is 16 dHdt. Divide 16 over, and I think that's 3. Divide by 4, that's 12 over 4. Yeah, that's 3. B. Alright, particle moves along the curve when y equals 2, dx dt is 3. What is dy dt? So I'm taking derivative with respect to time. This is going to be product rule. So derivative of x is not 1. It's dx dt, y squared, plus x. Derivative of y would be 2y dy dt. Derivative of 2 is just 0. Y equals 2. Dx dt is 3. Need to find x. So y equals 2, I'm going to plug in x2 squared equals 2. That's 4x equals 2, so x is 2 over 4, 1/2. 2y is 2. Looking for dy dt. This is 4 times 3 is 12. This cancels. 12 plus 2 dy dt equals 0. Subtract the 12 over, divide by 2. So then you get negative 6 is dy dt. On a certain day, the total number of pieces of candy produced in factory open is C. A function of the number of hours since it opened. What is the best interpretation of C prime of 3? So this means the rate of C at something equals 3. This is a function as the number of hours, so at t equals 3 hours. So then C is the total number of pieces of candy, so the rate at which the number of pieces of candy is increasing at t equals 3. So produces 500 pieces? No, because I want a rate. The rate, the factory is producing at a rate of 500 pieces per hour. Perfect. 3 hours after it opens, that would be at t equals 3. And the rate is increasing at a rate. That's a rate of a rate, and that's not what I'm given. I'm just given the rate of C. Oil is leaking from a pipeline on the surface and forms an oil slick of a right circular cylinder with both radius and height changing with time. So R and H are both variables. When the radius is 10 and the height equals 2, they both increase at a rate. So dr dt is, I'm just going to put it as 1/4, make simplifying easy, and dh dt is also 1/4. What is the rate of change of the volume? So I need to find derivative of volume. Here, these are both variables, so I'm going to use product rule. So derivative of pi r squared would be 2 pi r dr dt, and there's still an h, plus, leave this one alone, derivative of h is dh dt. Now we just plug in. dr dt is 1/4, height is 2, plus pi 10 squared, dh dt is 1/4. So 10 squared is 100. 100 divided by 4 is 25. There's still a pi. 2 times 2 would cancel out that 4. And then, so now I just have 10 pi. That's 35 pi. Radius is increasing at a certain instant. The rate of increase in the area is numerically equal to twice the rate in the circumference. So the rate of increase in the area, that's dAdt, is numerically equal to twice the rate, so 2 times the rate of increase in its circumference, so dc dt. What is the radius at that instant? Okay, so area of circles, pi r squared, circumference 2 pi r, derivative of each would be 2 pi dr dt, derivative of this one would be 2 pi r dr dt. So dA dt is just 2 times dc dt. dc dt is this, so that's 2 times 2 pi dr dt equals 2 pi r dr dt. 2 pi cancels, dr dt cancels, so r equals 2. We've got y equals 3 and dy dt equals 6. Find dx dt. Take derivative with respect to time, so 2y dy dt equals derivative of that 0 dx dt y plus x dy dt. Derivative of x is not 1 because we're not taking it with respect to x, we're doing it with respect to time, so that's dx dt. And now we plug in 2, 3, dy dt is 6 equals looking for dx dt, y is 3, plus need x, and dy dt is 3. So need to find x, so plug in 3 squared equals 2 plus 3y, x 3. 3 squared is 9, minus 2 is 7, equals 3x, so then divide by 3, so this is 7/3. 3 cancels, that's just plus 7, 3 dx dt, that is 6 times 6 is 36, subtract 7 over, so 36 minus 7 equals 3 dx dt, divide by 3, 36 minus 7 is 29 over 3. Is that right? I know I messed up. dy dt is 6, so this is 6 right here, so this is 14. So then minus 14 is 22 over 3. A ladder is 25 foot long, base of the ladder is pulled away, so I'm going to say this is 25, it's a constant, so I can call it 25 because it's not changing. I'm going to call this y and x. The base is pulled away at a rate of 2, so that would be like the x, so dx dt is 2. How fast is the top moving? So dy dt when it's base, so x equals 7. So x squared plus y squared equals 25 squared. This one's actually a constant. Don't call it z because then you'll get confused because it's not actually a variable. 2x dx dt plus 2y dy dt equals 0. X is 7. Dx dt is 2. Y would be 7 squared plus y squared equals 25 squared. I think I cheated and used a calculator on this one because it's not a nice one. So this one, y equals 24. 24 dy dt equals 0. This is 14, 28 plus 48 dy dt. Subtract the 28 over, divide the 48. And divide by 2, that's 14 over 24. Divide by 2, that's negative 7 over 12. It makes sense that it's negative because the y would be decreasing going down. The rate at which water leaks from a tank in gallons per hour is modeled by r, a differentiable function of the number of hours. So this is r of t. Which of the following is the best interpretation of r prime of 3? So r prime of 3 is the rate of r at, this one's a function of time, so at t equals 3. Let's think of our units. That would be dr dt. The r is measured in gallons per hour, so that's gallons per hour, divided by time, which is hours. So see how our units are actually going to be gallons per hour per hour. So the rate at which r is changing in gallons per hour at t equals 3, and r is the rate at which the water leaks from the tank. So the rate of which the water leaks from the tank in gallons per hour at t equals 3. The amount of gallons, no, definitely not. The amount of change in the rate, 3 hours. So the gallons per hour doesn't make sense because we said it would be gallons per hour. The rate at which water leaks from a tank in gallons per hour. So that's what, if I just plugged in r of 3, see how that's what that would be? I want r prime. So the rate of change of the rate, so the rate of r, in gallons per hour at t equals 3, or 3 hours, so d. Good luck guys studying.